Welcome to TechPrint YouTube channel. In today's video, we are diving into an exciting topic for all of you IoT and data enthusiasts. How to use RabbitMQ and PostgreSQL to build real-time IoT dashboards. Whether you're creating a smart home project, monitoring environmental data, or building industrial IoT system, this setup can handle the constant flow of sensor data effectively. So if you're ready to take your IoT data pipeline to the next level, keep watching. Let's first look at what we are building. Imagine you have IoT devices or sensor deployed in various locations. They are constantly sending data, temperature readings, humidity levels, or even motion detection signals. This data has to be processed and stored somewhere so that you can analyze it, visualize it, or trigger alerts. That is where RabbitMQ and PostgreSQL come in. Here, RabbitMQ will act as a message broker, collecting data from your IoT devices and then handling it over to PostgreSQL for storage. PostgreSQL will then store this data in a format that is easy to query for our dashboards. This way we separate the data ingestion process from the storage layer, making it more efficient and scalable. Why RabbitMQ and PostgreSQL? Good question. RabbitMQ is a fantastic choice for real-time message processing because it is lightweight, flexible, and perfect for handling high throughput. It lets us handle all incoming data smoothly without overwhelming our database with constant writes. On the other hand, PostgreSQL is a reliable, powerful relational database that is great for querying structured data and generating insights on the fly for dashboards. Let us take a quick overview of what we will be talking about today. We are going to go over what RabbitMQ is and why it's useful, what PostgreSQL is and how it stores data, and what an IoT dashboard is and why it is key for monitoring and visualizing data. First up, what is RabbitMQ? In short, RabbitMQ is a message broker. Now, what does that mean? Imagine you have a lot of messages or data points coming from different IoT devices. Instead of sending each one directly to your database, you can route them all through RabbitMQ first. This gives you a couple of big advantages. RabbitMQ makes sure each message is handled efficiently. Even if you're getting thousands of messages per second, it also lets you set up multiple consumers to process this data in parallel. So, it is super useful for managing high volumes of data and makes your system more scalable. Simply put, RabbitMQ helps us manage and streamline all of our incoming data, which is crucial in IoT systems where data flows can be intense. Next up is PostgreSQL, a powerful relational database system that is great for storing and querying structured data. PostgreSQL, or Postgres, as people often call it, is known for its stability and flexibility, which makes it an excellent choice for handling IoT data. One of the reasons PostgreSQL is so popular is because of its robust support for different data types and powerful querying capabilities. With PostgreSQL, you can store complex IoT data in tables and then run queries to get exactly the insights you need. And it integrates well with RabbitMQ and dashboard tools, making it a perfect fit for real-time data storage and retrieval. So in our setup, PostgreSQL will act as the brain where all the IoT data is stored and organized, ready to be accessed by our dashboard or other applications. And finally, Let's talk about IoT dashboards. This is where all the data and hard work come together visually. An IoT dashboard is essentially a real-time interface where you can monitor, analyze, and interact with your IoT data. Imagine you have a system with temperature and humidity sensors. On your IoT dashboard, you can see live temperature and humidity readings, view historical trends, or even set up alerts when certain thresholds are crossed. It is all about making the data accessible and actionable. Dashboards turns raw data into something you can see and understand instantly, making them incredibly valuable in IoT environments. Let's kick things off with why this integration is so powerful. RabbitMQ is a message broker and PostgreSQL is a relational database. But together, they can build a highly efficient pipeline for handling large streams of IoT data. And that is exactly what we need for IoT dashboards: scalable data ingestion, reliable message delivery, asynchronous processing, and centralized data storage. So let's dive into these points one by one. The first benefit of using RabbitMQ with PostgreSQL is scalable data ingestion. IoT systems can generate massive amounts of data, especially when we are dealing with multiple devices. RabbitMQ acts as a buffer, collecting data as it arrives and ensuring that PostgreSQL doesn't get overwhelmed with incoming requests. So, instead of bombarding the database with thousands of data points every second, RabbitMQ takes on the load. This keeps the whole system responsive and allows PostgreSQL to handle data at its own pace. Think of RabbitMQ as a control center that handles data flow and make sure that PostgreSQL can keep up, even if there is a huge spike in data from your IoT devices. Next up, asynchronous processing. This is a big one because with IoT, data doesn't always need to be processed immediately. RabbitMQ let us process messages asynchronously, meaning that data can be ingested, queued, and processed later when resources are available. This makes the system more flexible, even if the database is busy with other tasks. RabbitMQ holds onto the messages, allowing the system to keep receiving data without any interruptions. When PostgreSQL is ready, it can handle the data at its own pace. With asynchronous processing, we are no longer tied to real-time data processing, which is especially helpful in IoT where data flows can vary a lot throughout the. Moving on to reliable message delivery. RabbitMQ is known for its durability and reliability. In IoT, data loss can mean missed events or inaccurate analytics. RabbitMQ uses a queuing system that ensures messages are not lost even if the system temporarily goes offline or encounters errors. So, no matter what happens, you can be sure that every piece of data from your IoT devices is accounted for and delivered to PostgreSQL. This reliability is crucial when dealing with important data like environmental metrics, equipment status, or safety-related information. With RabbitMQ's reliable delivery, you can count on your IoT system to capture and retain every important piece of data, giving you confidence in your analytics and dashboards. Finally, let's talk about centralized data storage with PostgreSQL. Once RabbitMQ collects and manages the incoming messages, PostgreSQL steps in to store this data in a structured and accessible way. This centralized storage enables your IoT dashboard to pull data from a single organized source. This setup makes it much easier to run queries, build analytics, and visualize trends over time on your IoT dashboard. Plus, with PostgreSQL's support for complex queries and indexing, you can quickly access and analyze the data that matters. With all your data in one place, PostgreSQL has become the backbone for your IoT dashboard, enabling you to gain insights and make data-driven decisions with ease. So that is why RabbitMQ and PostgreSQL make such a powerful combination for IoT dashboards. With scalable data ingestion, asynchronous processing, reliable message delivery, and centralized data storage, you're setting up a system that can handle the challenge of IoT data in real time. To keep things simple, let's break down the process into 4 main steps, starting from how the IoT Internet of Things devices connect all the way to how data is displayed on the dashboard. Here's the architecture at a glance. Step 1. IoT devices publish sensor data to RabbitMQ. Step 2. A consumer listens to the RabbitMQ queue and processes messages. Step 3. Process data is saved to PostgreSQL. Then the last step, the IoT dashboard queries PostgreSQL to display the data in real time. Let's start with step 1. Here, IoT devices publish sensor data directly to RabbitMQ. Think of RabbitMQ as a traffic controller that receives and organizes incoming data from all your IoT devices. This might include temperature, humidity, light levels, anything your sensors are measuring. RabbitMQ is designed to handle a high volume of incoming data, making it perfect for real-time IoT data streams. By centralizing data in RabbitMQ, we make sure piece of information is captured in an orderly and reliable way, setting the stage for smooth processing in the next steps. Moving on to step 2. Here, a consumer service listens to the RabbitMQ queue. This consumer application is specifically designed to fetch and process each message as it arrives in the queue. Think of it as the listener that constantly watches RabbitMQ and grabs new data as soon as it's available. This allows us to process the data asynchronously, meaning the IoT Internet of Things devices can keep sending data without waiting for it to be processed immediately. The consumer app makes sure everything moves along efficiently, preparing data for storage in the next step. On to step 3, saving your data into Postgres. Once the consumer processes each data point, it then sends it to PostgreSQL, our database for centralized storage. PostgreSQL stores all processed data in a structured way, allowing us to easily organize, query, and analyze it later. By saving this data in PostgreSQL, we are setting up a reliable database that holds all sensor readings. Whether you're tracking trends or performing historical analysis, PostgreSQL provides the speed and flexibility you need. Finally, step 4. The IoT dashboard displays data in real time by querying PostgreSQL. Here's where the end user experience comes in. The dashboard continuously queries the database to get the latest data, and it refreshes automatically to display new information as soon as it arrives. This setup allows us to see live sensor data as it flows in. So whether it's temperature spikes, humidity changes, or other critical metrics, the IoT dashboard keeps everything at your fingertips in real time. And that is it. This architecture gives you a reliable, efficient, and scalable pipeline for handling IoT data, from collection and processing in RabbitMQ to centralized storage in PostgreSQL and live visualization on your dashboard. First up, let's recap on RabbitMQ. RabbitMQ is a message broker that allows IoT devices to send data through message queues. It is essential for efficient, scalable data flow. So, if you're managing multiple data sources or want to process data asynchronously, RabbitMQ is a must. If you haven't already, you can download RabbitMQ from their official site, install it, and follow the setup instructions. Once it is installed, you also need to configure your message queues. These are what keep your data organized and ready for processing. Next, we have PostgreSQL, our database of choice for storing and organizing all IoT data. PostgreSQL is known for its reliability and performance, especially for large data sets, which is exactly what we want for IoT projects. So, to get started, download and install PostgreSQL. Make sure it's up and running so we can connect it later using Python. We will set up a database specifically for the IoT data to keep everything clean and organized. Now, let's talk about Python, the powerhouse of our setup. We will be using Python to write the code that connects RabbitMQ to PostgreSQL, as well as the dashboard itself. We will need a couple of key libraries, Picker for interacting with RabbitMQ, scalable for working with PostgreSQL. Make sure you have Python installed, then install these libraries. Then before you install this library, and also make sure you create a virtual environment by running the following command. Then after creating your virtual environment, the next thing to do is to activate the virtual environment by running this command. You can see we've successfully activated our virtual environment. Install these libraries by running the following command. You can see requirements already satisfied, which means I already have these two libraries installed. These libraries will allow us to pull data from RabbitMQ and push it to PostgreSQL with ease. And for the dashboard, we are using Flask, a lightweight web framework that makes it easy to build dynamic dashboards. Flask is great for this purpose because it allows us quickly create routes and render real-time data on a web page. If you haven't used Flask before, don't worry. It is super simple to set up. You can install it using the following command: pipe install Flask. I already have that installed. Likewise, we'll walk through building a basic dashboard to visualize our IoT data. And last, but definitely not least, Docker. If you want to simplify your setup and avoid any local installation headaches, Docker is a game changer. With Docker, you can run RabbitMQ, PostgreSQL, and even Flask in isolated containers, making it easy to spin up or tear down your environment as needed. Just install Docker Desktop, then find and pull the official RabbitMQ and PostgreSQL Docker images. Docker makes it so much easier to manage dependencies and ensure everything is compatible. Alright, so to recap, here is what you need for this setup: RabbitMQ for message queuing, PostgreSQL for data storage, Python with libraries like Picker and scalable, Flask for creating a live dashboard, and Docker if you want an easy setup without installing everything directly on your machine. But in this tutorial, we're going to install everything directly on our machine, so which I did already without using Docker. Let's start with Linux user. Getting RabbitMQ installed is straightforward and only takes a couple of commands. First, open your terminal and run this command to install RabbitMQ. This will download and install RabbitMQ and all its dependencies. Once the installation is complete, you will want to start the RabbitMQ servers. To do that, simply type sudo system control start RabbitMQ-server. And that is how to install RabbitMQ on your Linux system. If you ever need to stop or restart it, you can use the sudo system control stop RabbitMQ-server or sudo system ctl restart RabbitMQ-server respectively. Now, for all the Mac OS users, you will want to use Homebrew to install RabbitMQ, which makes it super easy. Open your terminal and enter brew install RabbitMQ. I use Mac OS and I already have RabbitMQ installed on my machine. So you can use the command as shown on the screen to install RabbitMQ on your own machine. So Homebrew will handle the download and installation. Once it is installed, we will start RabbitMQ as a background service with this command: brew services start RabbitMQ command. After running all these commands, RabbitMQ should now be running on your Mac. With Homebrew, managing services like RabbitMQ is straightforward, and you can use brew services stop RabbitMQ to stop it when needed. Alright, for Windows users, the process is a bit different. You will want to head to the official RabbitMQ website to download the installer as shown on the screen. Go to rabbitmq.com/docs/install-windows. From here, download the installer file and run it. Make sure you have Erlang installed. As RabbitMQ depends on it, the website has links to Erlang downloads, so grab that first if you don't have it installed. Once RabbitMQ is installed, you can start it using the command prompt by navigating to the RabbitMQ sbin folder and running RabbitMQ server.bat. This will start RabbitMQ as a standalone service if you do like to install it as a Windows service, so it starts with your computer. There is also an option to set that up during installation. Now let's explain how to install Postgres on your machine. Let's start with Linux. PostgreSQL is easy to install with just a couple of commands. Type the following command as shown on the screen to install PostgreSQL and some useful add-ons on your Linux machine. So this command installs both PostgreSQL and additional tools that make managing your database easier. Once the installation is complete, PostgreSQL will start automatically. You can check the status of the PostgreSQL by typing the following command on your Linux. Like I said, I use Mac OS, so I won't be running this command. If it's running, you are good to go. If it is not running, you have to start it with sudo systemctl start PostgreSQL, and that is it. PostgreSQL will now be set up on your Linux system and ready to use. Let's move on to Mac OS. The easiest way to install PostgreSQL on Mac OS is with Homebrew. Open your terminal just like I did to install PostgreSQL on your Mac OS with the following command. Homebrew will handle the download and installation process for you. Once it is installed, I already have it installed on my machine, so I won't be installing it. Once it is installed, you can now start the Postgres service. Brew services starts PostgreSQL. So once it is installed, let us start the PostgreSQL. Brew services start PostgreSQL. Yeah, I have version 14 of it installed on my machine. You can see it said service PostgreSQL 14 already started. I already start these services, so I don't need to restart it again. Homebrew makes it simple automatically setting on PostgreSQL to run in the background. You can check if PostgreSQL is running by using brew services list. If you ever need to stop it, brew services stop Postgres. Like I said, I have version 14 of it, so that's why I'm using the following command. You can see stopping PostgreSQL might take a while. So you can see I've successfully stopped PostgreSQL from running in my machine. So now I can restart it using the brew services start PostgreSQL. You can see I've successfully started PostgreSQL on my machine. And there you've learned how to install PostgreSQL on both Linux and Mac OS. Now you're ready to create and manage database for all your projects. First thing here, we're going to start by creating a new Python file named send.py. The first thing we're going to do here is to create a directory on a desktop. You can name it and give it any name, but I'm going to name it RabbitMQ. All right, we're going to start by creating a Python file named send.py. Send.py. Right, we've created the file. This file will contain all the code needed to publish data to RabbitMQ as if it were coming from an IoT devices. Now, let's open a Visual Studio Code. Okay, we have a Visual Studio Code opened here. So first, we're going to import the required libraries. We will use Picker to interact with RabbitMQ and JSON to structure our data in JSON format. Here's how we start. You import Picker, then import JSON. We will set up the connection to RabbitMQ and declare our queue. In this example, I'm connecting to RabbitMQ running on localhost, which is common when testing on your local machine. Once connected, we'll declare a queue named IoT queue, which will be the destination for our data. Now, let's define some example IoT data. Imagine this data coming from a temperature and humidity sensor. We are setting up a dictionary with fields like device_ID, temperature, humidity, and a timestamp to represent our sensor's reading. We have the sensor data, right? Temperature, yeah. We have to add a device ID. It's going to be sensor_1. So it's gonna be a string. The temperature was set it to 25.5, right? Humidity 60. Then let's give it a timestamp. Let's take out this light intensity and sound level. Let's add timestamp instead. Now we're ready to publish a message. We use tunnel basic_publish to send our sensor_data to IoT queue. Now we're ready to publish a message. We use tunnel basic publish to send our sensor data to IoT queue. We convert our data into JSON format with JSON.dumps since RabbitMQ works with byte messages. When the message is successfully sent, it will print out IoT data sent on the console. That's a quick confirmation that our data has been published to the queue. Finally, we close the connection. It is important to do this at the end of our script to free up resources. To test this out, just save the script and run it on your terminal or command prompt with command python send.py. You can see sent IoT data has been displayed. You should see the message confirming that data was sent just like this. And that is it. You now have RabbitMQ publisher simulating an IoT device. Next, open a new Python file and name it receiver.py. You can do that here. Receiver.py. This file will contain our code for consuming messages from RabbitMQ and inserting them into PostgreSQL. We will start by importing the libraries Picker for RabbitMQ, JSON for handling our data formats, and PsycObj2 for PostgreSQL interaction. To establish a connection to RabbitMQ, we'll connect to localhost, which is where RabbitMQ is running on our local machine. We'll also declare our IoT queue again and ensure we're working with the correct message queue. So let's declare a queue. Okay. Next, we'll set up a connection to PostgreSQL. Be sure to replace database, user password, host, and port with your own data. Then we have our host to be local host. Then we have our ports to be 5432. So the corporate function will be triggered whenever our consumer receives a message from IoT queue. Inside this function, we will convert the message from JSON formats and print it to verify it's working correctly. Then we'll insert the data directly into our PostgreSQL database. This is where we define our insertion query, which takes the device ID, temperature, humidity, and timestamp values from our sensor data and saves them in the IoT data table in PostgreSQL. Now, we tell RabbitMQ to start consuming messages from IoT queue using our callback function. The auto arc through parameters confirm each message to process, letting RabbitMQ know it can clear that message from the queue. This code will keep the consumer running, continuously waiting for messages to arrive. You will see each message printed in the console as it's received and stored in PostgreSQL. To test this, simply save the file and run it in your terminal with Python receiver.py, just like this. Python. Make sure your RabbitMQ and PostgreSQL are both running and watch as data gets inserted into your database in real time. And that is it for setting up a RabbitMQ consumer that processes and stores IoT data in PostgreSQL. Let's outline our table. We are naming it IoT data and it's structured to store key details from IoT sensors: the device ID, the temperature, the humidity, and timestamp. Additionally, we will create an ID columns to uniquely identify each entry. I already did this, but if you're yet to get it done, you have to install PostgreSQL and run on your terminal. For Mac user, run the following Postgres command. Next thing to do is to create your database. So there's a syntax error. Now you create your database just because I semicolon. So you have to create the database. You can see database created. So now let's switch to the database, newly created database, to insert, to create a table. So you can see you're now connected to database. Now let's create our table. You can see we've successfully created our table. We have ID column, which is set to serial primary key. This means PostgreSQL will automatically generate a unique ID for each new row, ensuring each entry in our table is unique. The device ID column stores the identifier for each device sending data. We set this as text and use not null to make sure we always have a device ID with each entry. For the temperature column, we use the numeric type, which can store decimal values, making it ideal for sensor readings that require precision. Similarly, the humidity column is also of type numeric, as it may include decimal values depending on the sensor readings. Finally, we have the timestamp column, which records the exact date and time each reading was taken. We use the timestamp type to ensure our data is accurate and time-stamped. Make sure you connect to the right Postgres database, just like I did here. We now have a dedicated table in PostgreSQL to store IoT data. I already created a table, an existing table, which I use IoT DB. I just use this as example of how this table was being created. Now let's set up our Flask app. We will create a file main.py. In this file, we'll write the Flask code for this project. Make sure you have Flask Psycopg2 and pytz installed in your environment. We import all the necessary library, then set up Flask app and write the function to connect to our PostgreSQL database. In this part, we create a function to get DB connection. This function sets up a connection to a PostgreSQL database where our IoT data will be stored. Replace database user and password with your actual PostgreSQL credentials. And we simulate IoT data from different devices. We create a function called insert random data. This function generates random values for temperature, humidity, and timestamp. This will add a new record to our database every time we call the function. Now we create the main route for our Flask app, which will render our dashboard. In this route, we insert random data each time the dashboard is accessed and retrieve data from the database. We also add functionality to filter the data based on the time range using start time and end time parameters from the URL. If these parameters are present, we will use them in our SQL query. To ensure our app handles errors gracefully, we wrap our database operations in a try-catch finally block. This helps capture any errors that occur during database fetching and ensure we always close our database connections. Finally, we use the render template function to send our data to a template file called dashboard.html, which we will create later. To start the application, go to your terminal and run the following command. This will launch your Flask app in debug mode on localhost. Now we have our Flask app that simulates IoT data, stores it in a PostgreSQL database, and renders it on a dashboard. In the next step, we'll dive into creating the HTML template for our dashboard. Now, let's create the HTML file. So next, let's create a templates directory. Inside this directory, let's create dashboard.html file. In this templates directory, we created a dashboard.html file. This will display the IoT data in a table and a line chart. Now let's add our HTML structure and import all the necessary CSS and JavaScript libraries, including Bootstrap for styling and chart.js for the charts. We imported all the necessary libraries that are going to be required for this project. Then we added date filter from. This allows user to specify a date and end time for the data displayed. Using Flask request handling, we can get these values and use them in our query. Below the date filter, we add a responsive table for displaying the data. Using Ginger templating, Flask dynamically inserts data here, like device ID, temperature, humidity, and timestamp. Then we add a chart below the table to visualize the temperature and humidity over time. We will use the charts.js to plot our data in a line chart. Flask sends the data as JSON to the template, and charts.js uses it to create a responsive graph. With everything in place, we can now test our application. Run Python main.py. Head to HTTP localhost 5000 in your browser to see your live dashboard. As you can see, each time I load the page, new data is inserted. You can also see that the table updates and the charts redraw to reflect the filtered data. Now we have a fully functioning IoT dashboard with live data and charts. Let's dive into the benefits of using RabbitMQ and PostgreSQL together. Starting with scalability. RabbitMQ allows you to process massive volumes of data by distributing tasks across multiple workers. This helps prevent bottlenecks, making your system capable of handling more devices as your IoT network grows. Next is asynchronous processing. With RabbitMQ, you don't have to wait for data to be processed immediately. It lets you queue tasks that can be processed in the background, allowing your IoT devices to send data continuously without interruption. Reliable message delivery is another critical advantage. RabbitMQ ensures that messages are delivered even in cases of network failures or power outages, helping you avoid data loss, essential for IoT applications that rely on continuous real-time data. And finally, structured data storage with PostgreSQL. IoT data often includes timestamps, device IDs, and specific sensor values. PostgreSQL structured relational storage formats helps organize and efficiently query this data, making it ideal for detailed analytics. Of course, no solution is perfect. Let's take a look at some of the downsides to consider. First up, complexity. Setting up RabbitMQ and PostgreSQL together can be challenging, especially if you're new to managing messages queues and relational database. Integrating these systems smoothly requires some configuration and tuning. Then there is overhead. Then there is overhead. While RabbitMQ is great for message handling, it introduces extra processing steps, and PostgreSQL structured formats can sometimes be slower than NoSQL databases when handling large amounts of real-time data. Lastly, the learning curve. Both RabbitMQ and PostgreSQL have their own intricacies. Learning to use them effectively requires understanding their configuration, monitoring, and troubleshooting, which can be time consuming for beginners. Now that we know the pros and cons, here are some best practices to make the most of RabbitMQ and PostgreSQL in your IoT dashboard. Optimize queue and message handling. Avoid overloading RabbitMQ with too many simultaneous messages by adjusting your queue and worker configurations. This will keep your data flowing smoothly without causing processing delays. Monitor system performance regularly. Use monitoring tools to track queue lengths in RabbitMQ and query times in PostgreSQL. This helps you identify potential issues before they impact your system's performance. Setting up durable queues in RabbitMQ is also essential. Durable queues ensures that messages are stored even if RabbitMQ restarts, providing an extra layer of reliability for your IoT data. Finally, use indexing in PostgreSQL. Creating indexes on frequently queried fields like device ID and timestamp can dramatically speed up queries, especially as your data grows over time. To wrap things up, RabbitMQ and PostgreSQL offer a powerful combination for handling IoT data. RabbitMQ ensures that data flows reliably from devices to your system, while PostgreSQL provides structured storage that is perfect for data visualization and analytics. Scalable solution. This setup works for small IoT projects and can scale up as your system expands, making it adaptable for future growth. Thanks for watching. If you found this video helpful, don't forget to like and subscribe for more tech insights and tutorials. Feel free to leave any question in the comments and I will see you in the next video. Happy coding!